In this video, we're going to learn how to multiply and divide in scientific notation. This will correspond to section 8.7 in the textbook. Before we get started, it's really important that we know how to multiply and divide with decimal numbers. If we don't remember, please complete the review that was sent to you. So let's just jump into our first example. We're going to be multiplying in scientific notation, and we've got 3 times 10 to the negative 5 times 5 times 10 to the negative 2. So what we really have here is that everything is just being multiplied together. So if I want to, I can rewrite this as 3 times 10 to the negative 5 times 5 times 10 to the power of negative 2. And then I can group things together that are like. So I see I have a 3 and I have a 5, and everything's being multiplied, so the order doesn't really matter. So I can do 3 times 5 first. So 3 times 5 makes 15. And then I can look at my exponents here. I've got 10 to the negative 5, and I've got 10 to the negative 2. So notice that I have two exponents with the same base. So we can recall our rule that we've learned about the product rule, which is a to the power of m multiplied by a to the power of n. We would just add our exponents. So a to the power of m plus n. So in this case, we've got now times 10 to the power of negative 5 plus negative 2, which gives us 15 times 10 to the power of negative 7. So now I've got 15 times 10 to the power of negative 7. However, when we're multiplying in scientific notation, we also want to give our answer in scientific notation. So if we look at the 15 here, we notice that that is not a number that is equal to 1 or greater than 1 in between 10. So what we're going to need to do now is rewrite 15 in scientific notation. 15 in scientific notation is 1.5 times 10. So if we notice that the red here that I've just highlighted, 15.5 times 10 is equal to 15. So they're equal to each other. And then I still have times 10 to the negative 7. And then from here, we can use our product law here. So we can see that we've got this section here, 10 to the power of 1 times 10 to the negative 7. Well, then I'm now going to have 1.5 times 10 to the power of 1 plus negative 7, which would give us 1.5 times 10 to the power of negative 6. So in this case here, our final answer for this question here is going to be 1.5 times 10 to the negative 6. And we have it in scientific notation that number is between 1 and 10, and I have got a power of negative 6 with my base of 10. Here in our second example, we're multiplying in scientific notation. I've got 5.6 times 10 to the power of 5 times 3 times 10 to the power of 9. So again, all of these terms are being multiplied together. So 5.6 times 10 to the power of 5 times 3 times 10 to the power of 9. Now if I want to simplify this, I'm going to have to multiply 5.6 times 3. So this is why we need to know how to multiply with decimals. So I've got 5.6 times 3. Now before I even do this multiplication, I'm going to estimate 5.6 is close to 6. So I'm going to round that to 6. 6 times 3 makes 18. So my answer should be close to 18. So my estimate here is 18. And then I can multiply. 6 and 3 makes 18. 5 and 3 makes 15. Plus 1 makes 6. And I've got 16.8. So I'm going to write 16.8 here, and then I'm multiplying this times 10. We got to figure out what the exponent is now, because if we notice here, it's 10 to the power of 5 and 10 to the power of 9. So now I can just add up those exponents. So 10 to the power of 5 plus 9, which is going to give me 16.8 times 10 to the power of 14. And then, am I finished here? Well, I have to pay attention. Is my answer in scientific notation? Well, in this case here, it's not in scientific notation because I have 16.8. So I need to rewrite this so that it is in scientific notation. So I'm going to rewrite this as 1.68 times 10, because 16.8 in scientific notation is 1.68 times 10. So now both of these two things that I've highlighted in red are now equal. And then I still have times 10 to the power of 14. Then I can notice here that I've got 10 times 10 to the power of 14. So if I want to simplify that, that's just going to be 10 to the power of 1 plus 14, which is going to be 10 to the power of 15. So now my final answer is going to be 1.68 times 10 to the power of 15. So let's jump into an example where we're dividing in scientific notation. So when we're dividing in scientific notation, I can rewrite this as a fraction as well. So I can go 9 times 10 to the power of 8 over 3 times 10 to the negative 6, since fractions and division are the same. And what I can also do is I can rewrite this as the product of two fractions. I can say 9 divided by 3 is being multiplied by 10 to the power of 8 divided by 10 to the negative 6. And then when I do this here, I can see that I can evaluate this fraction here, 9 over 3. Well, 9 over 3, or 9 divided by 3, is just equal to 3. So now I've got 3, and I'm multiplying this times 10 to the power of 8 divided by 10 to the negative 6. But we do remember that we learned that a to the power of m divided by a to the power of n is equal to a to the power of m subtract n. So I now have 10 to the power of 8 take away negative 6. So now I've got 3 times 10, and then 8 take away negative 6 is like having 8 plus 6, so that's going to give us 10 to the power of 14. And then I do a double check, is my answer in scientific notation? And it is, because it's between 1 and 10, so my final answer in this case is 3 times 10 to the power of 14. So looking at our last example, we have 5.6 times 10 to the power of 7 divided by 8 times 10 to the power of 4. So again, I'm going to rewrite this as a fraction. So over 8 times 10 to the power of 4. And we can split this up into a product of two fractions. So 5.6 over 8 is being multiplied by 10 to the power of 7 over 10 to the power of 4. So now we have to evaluate this fraction here. We've got 5.6 divided by 8. So 5.6 divided by 8, bring my decimal up at the top so they line up. 8 doesn't go into 5, but 8 does go into 56, so it goes into it 7 times. 8 times 7 makes 56, and I'm left with no remainder, so that's going to be 0.7. So now I've got 0.7, and that's being multiplied by this, and we have to work what that is. And again, we have that quotient rule. So what are we left with? We're left with 10 times 10 to the power of 7, take away 4. So now we got to work out what that is. So 10 to the power of 7 take away 4, well, that's going to be 10 to the power of 3. And I've got 0 times 7 times 10 to the power of 3. Now hopefully we're seeing that this is not going to work for us, because we are seeing that we do not have this in scientific notation. So here we have 0.7. 0.7 isn't going to work because it's not greater than 1, and it is not between 1 and 10, right? So we have to rewrite 0.7 into scientific notation. So 0.7 in scientific notation is 7 times 10 to the power of negative 1. So again, I'm hoping we're noticing that 7 times 10 to the negative 1 is equal to 0.7. And then now we have times 10 to the power of 3. And hopefully we can see here that we can simplify. So we've got 10 to the negative 1 times 10 to the power of 3. We're going to have to add those exponents. So we've got 10 to the power of negative 1 plus 3. And that's still being multiplied times 7, and then we can simplify this to 7 times 10 to the power of 2. And our final answer then is 7 times 10 to the power of 2. So here are 4 examples. You can try it on your own. If you get stuck, rewind the video and look at the examples again. Please remember to leave your answers in scientific notation and do that final check. So make sure before you say, like, I am done with this question, you check to see if that coefficient in front is between or equal to 1 and less than 10. So good luck with these questions, and see you in class.